The slope of a line segment is the ratio of how fast the line is going up compared to how fast the line is going over. So if we measure how fast we go from one point, the point -2, 0 marked on the line, we are going up 1, 2, 3, 4 steps and over 1, 2, 3, 4, 5, 6 steps in the x direction. So the ratio of the upward movement compared to the horizontal movement or the over movement is what gives us our slope. In this case, the slope equals 4 over 6. We would normally write that in lower terms as 2 over 3. And so going up 2 and over 3 should also get us to a point on the same line. Without a graph of our line and our points, it's still possible to find the slope using the slope equation. Here we have the equation for the slope of a straight line. The slope is referred to using the letter m, and it's equal to the rise, which is the up direction. Here's the rise, over the run, which is the over direction. Now we always go over to the right. We never move to the left when we're measuring the slope of a line. Now you'll notice that there are some other notations here in the equation. If m is equal to rise over run, then we see the symbol here with the triangle. And the triangle is really a Greek symbol, and that symbol is the actual letter D in the Greek alphabet. And it stands for the difference in the y values over the difference in the x values, and that is the Greek symbol delta, which is the letter D. In calculus, that triangle and the fact that it stands for the letter D changes somewhat, and we see the calculus slope formula written as dy dx. So it's really the same thing. Now, if we take y2 minus y1, then we are measuring from here down to here. In other words, we're measuring what the difference is in the y values of the points that we're given. So in this case, if we were calculating the slope without a graph, we would need our two y values. y2 is 4, that's the y value of the second point, and y1 is 0, that's the y value of the first point. For the x values, x2 is the second point's x value, so we're going to write a 4 in there, and x1 is the x value of our first point. Now be careful because that x value is a negative number, and so when we find the difference, we're subtracting -2. So 4 over 4 plus 2 is 4 over 6, or 2 over 3, and that's the same as the slope we found from the graph. A couple of interesting properties to keep in mind when you're working with the slope of a straight line is that slopes of parallel lines are identical. And that makes sense when you think about it. The slope of a line that's parallel is going to go up and over the same amount as another line that has that same slope. And so when we see two equations with the same slope, we can immediately know that those two lines are going to be parallel, or that those two lines will never intersect. If we have two lines that are perpendicular to each other, there's also an interesting property with their slopes. If we look at the line with the positive slope, this line here has a positive slope because it's going uphill, then the rise of this line, counting up from -2 to 3, the rise is 5, and the run from -6 to 2 is 8. So the slope of this line is 5/8. Now the slope of the red line is going to be a negative slope because that line is going downhill. And the slope of that line, if we can find two good points on that line to measure it, we're going down 8, which we would show as a -8, and over 5 in the horizontal direction. So the slope of this line is -8/5. So when we compare the slope of this line to this line, and we know that these two lines are perpendicular because they're marked as meeting at 90 degrees, or in a T intersection might be an easier way to remember it. You notice that the slopes are reciprocals. Reciprocals means that we've flipped the top and the bottom values over, and also that one slope is negative and the other slope is positive. So we call those negative reciprocals. And the slopes of perpendicular lines are negative reciprocals. And one way to write that would be that if we have M1, it would be equal to -1 over the slope of the second line. And so those properties will also help you, believe it or not, in courses like calculus when you're trying to find the normal or the perpendicular to a line or a plane. Then all of these slope properties will come back into play, and so it's really important to understand them and be able to work with them.